So
Hi!
sorry.
Let's not keep Athena silent for a long time. And I'd like her to tell us all about herself. Lots of people know her. Lots and lots of people know her. They have seen you in movies and, Instagram account. Your Instagram account is so amazing. So I'm sure that people just want me to shut up now and let you start talking.
Oh, you're so incredible. And I absolutely love what you've built at AstronEra. I'm so excited to be part of it and to be able to like bring a course together. I remember when we were trying to come up with, I guess, kind of the idea of what the course should be. And I think I sent you guys some crazy name for how the course should be. But then after looking through what the materials are, you guys suggested like this kind of sounds like a starter pack for astronomers. And so I'm just really excited to sort of bring everyone this sort of introductory view to the world of astronomy. And yeah, and introduce all of you guys who are going to be in the course. I can't wait to meet you guys. I mean, I'm going to be meeting you guys now, I guess, and then probably after the course in another Instagram live. But yeah, I'm really excited about that because, you know, like if it wasn't for astronomy, I wouldn't have the views that I have of like our planet, of like my friends, of everyone that's I think in my life. And astronomy has really been like a huge aspect of who I am and who I became who I am. And so to be able to introduce that to I think some people, it's just going to be so exciting. So me specifically, I grew up in New York City. Went to a high school in Brooklyn called Edward R. Murrow, and that's where they had a planetarium. So that's where I first learned and was like introduced to astronomy. I learned how to track asteroids, and it was just so exciting. So that's something we're going to be exploring as well in the starter pack, is like the different tools astronomers use to do things like track asteroids, to do things like map the night sky, how to navigate the night sky, and also how to navigate here on Earth by using the constellations. I mean, that's what humans used to do, like, you know, centuries ago, before we had Google Maps, before we even had, you know, like, I guess like early compasses. A lot of times, people just tried to use the stars to understand which direction was north, which direction was, you know, the nearest village, et cetera, et cetera. So I think that being able to have that that tool or that ability is going to be a pretty powerful thing. So yeah, so anyway, I guess kind of back to me a bit. I then went to the College of Staten Island out here, super like random city, University of New York school, but it was the only one in New York City that had an observatory on campus, a huge observatory. I mean, you'd get to campus, the first thing you see is the observatory with massive telescopes inside.
Is it like a big dome?
Yeah, huge dome. It was the first time I looked at the sun with the H alpha filter. So was able to look at sunspots. I mean, it was extraordinary. I mean, like, have any of you guys seen like, I guess maybe videos from NASA or maybe from Parker Solar Probe of the sun and its movement? I mean, it's so cool. And so imagine being able to see that through an H alpha filter. Definitely need a filter in order to look at the sun through a telescope. It's just so extraordinary. It's really like actually a ball of fire. It's just so exciting. Yeah. So kind of sad news about the observatory. I also signed a petition about it as well. But I think that nature just sort of took over. But the way I try to look at it is, although like, yeah, it was such a bummer for radio astronomy, is like, I really hope this opens new doors for like new like radio telescopes, new forms of radio astronomy. I mean, there could be something that's going to be developed by you guys 10 years from now. You could develop the first massive, maybe the world's biggest radio telescope, and it'll be in India. You know, like we have no idea right now unless we start to plan it. And so that's something that I'm just excited to be working with you guys on, because I feel like you're really inspiring the future generations to pursue astronomy.
Oh, thank you.
Yeah.
When exactly was it when you decided that astronomy is something that you want to model, and how did you kind of collaborated both of these fields together? Modeling and astronomy, kind of is a rare combination. So anything about that?
Yeah, I think you cut out for a second, but I kind of got the gist of it. Like wanting to pursue astronomy and then how modeling happened and how I balanced the two.
Yeah,
think
yeah,
it's kind of
exactly.
interesting.
That's the gist. Yeah.
Yeah, I mean, it's definitely strange, that's for sure. But I think what I've really enjoyed about it is understanding that, like, you know, your job or your career doesn't necessarily define like your interests or who you are. Sometimes people are working, you know, in jobs, but they're absolutely passionate about like another subject. And something that I've just been about with pursuing being astrophysicists who are obsessed with musical theater, you know, who love like either like dancing or theatrics, and then meeting models that are like mathematicians or absolutely love like chemistry and astrobiology. And so that's really brought such a different worldview to me. Also, because I've gotten to travel the world through the modeling career. Because of that, I've met astronomy organizations. I've been able to go to like other astronomy departments around the world, and that was because of modeling, which is so random. But I'm like, I want this. I want to find a way to connect to, I guess, like other people around the world. And that's allowed me, I think, to just understand too, is like the different space programs, but then also like say the different fashion. And it's also a big intermixing thing that I think we see a lot today too, is there's so much space clothes that exist. I mean, this was made by a hand painted design.
Wow.
And it's, you know, and it's like a combination of like this tie-dye and then like, you know, the planets. And I think that that's just so extraordinary, seeing the overlapping of different industries. And so going into astrophysics in university and then start to pursue this like acting and modeling careers, it really kind of like allowed me to understand that life is more of like a hybrid of different things rather than just one tunnel vision direction. But what I really love though about like, I guess, university is my time that I got to do some research. It was just such an extraordinary experience. I mean, I didn't quite know what to expect when I was going into astronomy as a degree. Like, I think a lot of people when they're younger, so when I was like in high school and in middle school, I was like, I'll just be looking through a telescope most of the time. And maybe a lot of you guys, if you're about my age or you're, you know, older, you're over 18, you probably know that that's not the case for astronomers. You're not just looking through a telescope all the time. You're actually a data analyst. Most of your work is understanding how to analyze data, how to code, because when you're collecting data from large telescopes, like say the Hubble Space Telescope, you're collecting a whole bunch of information of like, you know, spectral graph. You're understanding like what what the chemical makeup is of like the star, what elements are present. And then at the same time, you're measuring things like temperature, or you're measuring distance, you're measuring all these different aspects, but it all comes down to numbers, and then putting that into, you know, putting it into code, figuring out what your goal is with it. So what I mean by that as an example is I was studying protoplanetary disks, which is like the stage like before solar system for like our solar systems. And my excitement behind that was like, okay, I want to eventually try to find like the probability of planets being able to survive without completely getting blown apart by the stellar radiation, the stellar winds from either the newborn star or other nearby stars, because they all form in a big gaseous dust cloud known as the Orion Nebula, like my pillow over there. And I was like, okay, well, I'm going to figure out like what the amount of mass that's lost, so the mass loss rate. And pretty much I just had to look at a whole bunch of like data and information and process that, and then be able to figure out, okay, like where is the parameter where enough of it can sustain where a planet can eventually start to form. And if too much of the mass is being lost, then I got to remove that probe lid. I can't look at that because it means it's probably gonna completely expel all of that matter and that material. And if that's the case, then, you know, it's not going to survive for a planetesimal to form, which is like a lumpy early form of a planet, eventually a planet, and then possibly eventually finding out about habitability. And so that's kind of like the really early steps to eventually like the SETI project, which is to eventually try to communicate with an intelligent life form elsewhere in the universe. But I think that it's still really important. That adds into the calculation of, you know, how many exoplanets are out there. So this would be, okay, how many possible exoplanets can form? So I was like, really, really passionate about it. Also because, you know, the Orion Nebula formed through the death of a star, and yet it's seeding new star life. It's a stellar history, and I love that recycling process in space. I just think it's so awesome. So it's one of the courses, or I guess one of the classes that we have in this course for the starter pack to astronomers, is exploring that concept of how space recycles.
Okay, so I think lots of people want to get into astronomy. At least in India, I see that we have a few chapters when we are studying in school, and after that they do not know what to do with it, how to pursue astronomy later on. And at least in India, lots of people end up getting into engineering, and then they want to go into NASA or Indian Space Research Organization and stuff like that. But what astronomers do is also important, the physics part, the theoretical part as well, and not just engineering. So all the fields are kind of somehow connected with astronomy. And so even if you don't go into some big astronomical universities to study about it, you can still become an astronomer. You don't always need to be an engineer to be one. You don't always need to have a physics degree, mathematical degree to be an astronomer. In fact, there is lots of astronomical stuff that you guys can do while sitting at home, you know, without such degrees or such big knowledge about it. So I think that's what also you can discover with this starters pack. So do go through all these. We are going to also come up with a Discord account where we will add all the students who have enrolled into this course, and you'll be able to chat with me and Athena and ask your questions there, and we'll also be able to answer there. So
I'm excited about that. I didn't know that. We're gonna have a Discord channel. That's awesome. So that way I can like connect with you guys. It'll be kind of like our forum, I guess, to like go through the course. Am I gonna be able to like format questions based on each class for my students? And I would love to do that, because I'm excited. You guys are going to get some great tools that we're going to be like exploring and learning that I learned in school. So I'll be able to like formulate questions for them.
Yeah, you will be able to formulate questions for them as well. So we will see if we could do that on our website or on Discord. We are going to release the first session on next Monday, and then every Monday we are going to release the further sessions for next 6 weeks. So it's gonna be an amazing month and a half for everybody studying astronomy, getting into astronomy, starting in astronomy.
Best time too. Is like these are some of my favorite constellations during this time of the year, at least for the northern hemisphere, but we're going to be exploring both the northern and the southern hemisphere, especially in with some of the tools that we're going to be using, which I cannot wait for. So everyone know your longitude and latitude. Just giving a heads up, a little tip for one of our classes. Know your longitude and latitude for where you are, because that's going to be very helpful for one of them. Just little sneak peek.
And do you also have like some softwares that everybody can use on their own? Are you also going to explain anything about them so that we can download them on our own and get into it?
Yeah, so some of the stuff that we'll be exploring is going to be, so we're going to be using like a virtual star chart. So back in my day, probably with you as well, we had a printout of our star chart when we were learning the constellations and like at what time they'll be visible, when they cross the ecliptic, et cetera, et cetera.
I think I did have it somewhere over here.
Wait, is that Einstein? Is that a little plush Einstein?
Yes, it is.
That is awesome. Wow. I need to get one of those. It's so great.
It's so cute. Yeah, I actually got it from London, from the Natural History Museum.
That's so great. Oh, that is awesome. That's awesome. So what was I say? Oh yeah, so we'll be using a virtual star chart. And then one of the courses too is something really important, I think, in astronomy, especially if you guys are looking into possibly doing either astrophotography, not just here on Earth, which is kind of more of like a hobby, but learning how to process images. That's something that, I mean, if you go on like just like nasa.gov and you look at the raw images taken by like Hubble of different nebulae, most of the time they're kind of boring. They're like black and white images, and they don't get colorful until you actually like add in like, say, the temperature difference filter, or you're adding in like the spectrograph, and you're understanding like the differences. of what's present in what part of, say, the nebula or the galaxy. And that's something that I'm going to be doing as well. And the course is a really helpful tool with understanding like how we're going to be able to process the different images. And I think it'll be fun because that way we can actually like process our own. Yeah,
exactly. DIYs are the best, like something that you can do on your own on your laptop, or you know, if you can create some model on your own and go out and observe, that's perfect. I love DIYs, and you know, this course is so interesting because it has DIYs, it has this interactive thing that everybody has. So these courses that we have in AstronEra, even though we are gonna do them live right now, they are going to be available up there forever. So even after the video is released, you can watch it whenever you want. Even if you miss the live release, you can still later on go up there and watch it. So once you enroll, it's going to be for you forever. So you can revisit all those videos again and again.
Honestly, like astronomy is heavily reliant on computer science. As we were mentioning earlier, is most of the time you're coding vast amount of numbers. You're going to want to code in, say, like a specific equation to be able to calculate things like I mentioned, like the mass loss rate of a planetary disk. It would take a really long time for thousands of numbers and thousands of arrays, and so collections of data. So when you take an image of a certain area of the night sky, you don't just want to take one. Sometimes you'll rent a telescope. So if you're doing a research program and you know you're doing it for like a summer, you actually get time where you can use, say, the Hubble Space Telescope, point it in the direction of the object you're observing, and set up, say, like 20 hours of observation time that you booked. So you're going to be collecting 20 hours worth of data and information that you then have to go through. And so computer science is vital for that, to be able to go through all that information. When I was undergrad, my mentor, Dr. Charles Liu, absolutely love him, gave me this huge book on how to learn Python programming. And he just like dropped it on my desk. It was right when Python like just came out. And it was like, I guess, yeah, it just started trending, I think, in that year. It was like 2010, 2011. And he just dropped them and was like, teach yourself how to code Python. And I was like, and I learned enough for my reading, but that was something that was so important. So if you guys are learning computer science, you're already ahead of the game for astronomy, because that's going to be really important if you want to do research. If you want to actually pursue astrophysics research and contribute to whether it's galaxy collisions or it's doing something like what I was doing with Proplets, being able to code is going to just, it's going to be widely beneficial.
And yes, AstronEra does provide certificate after completing all the videos. So these videos will be uploaded on astronera.org. That's our website. You can find Athena's course there. There are so many other courses as well. So you can choose whichever course you want, and you'll see all the lectures there. So once you go through all the lectures, your certificate will be generated digitally, and you can download it and print it if you want. So even for Athena's course, for the starters pack for astronomers, we are going to have certificate. So you'll be able to get that in January, because we are going to upload lectures every week. It's gonna be like an interactive course for a month and a half. So that's the most interesting thing. And then later on, you'll get certificate in January. So I think around 17th of January, we'll go live again to do the last session, which is also going to be on Instagram. And after that, you can get your certificate online.
Amazing. Oh, I actually didn't even know about that. It's so exciting. I feel like that's such a cool way to sort of start the new year as well, as like a new astronomy course, like an astronomy certificate. You and then also Sarvesh asked about electronics engineering and astronomy, and I think there are quite a lot of overlaps when it comes to, I mean, what do astronomers use to observe the night sky? Like telescopes. They use like spacecraft. They use telescopes in an airplane that's flying overhead to detect like really exciting things, I mean, like Sophia, I'm referring to Sophia right now. And there are so many, and that's how we were able to detect like new water found on the moon in like glass beads, water molecules, because of an airplane with the telescope inside. I mean, that's just extraordinary. So if you're an engineer there are so many things that you have already contributed, or your industry has already contributed to astronomy. And I'd love to just see like what other developments can come in the future from future engineers for working on like maybe new optics, new forms of yeah, possibly spacecraft and stuff like that. But so I just wanted to touch on that because I thought that was really awesome. So another question like in the chat about going to Mars and like what our current rocket technology is. I mean, if you guys have been following SpaceX, which I'm sure you are, just because anyone who's kind of interested in space is probably aware of SpaceX, but if you're not, if you've been seeing recently with SN8 Starship, so the most recent serial number 8 Starship, which is out in Boca Chica, Texas, that's just extraordinary. I mean, if you haven't seen the images, go to like Tim Dodd, the Everyday Astronaut, and like check out, like, I mean, he's covering it. S. Padre is covering it. I mean, there's so much awesome stuff that's happening right now. Just and Starship is going to be what's going to be on the moon. So it's going to be meeting the SLS and the Orion spacecraft on the moon for the Artemis program. There's so much development right now just being done around that. And I'm sure there's going to be so many more missions going to the moon from ISRO. Do you say ISRO or do you say ISRO?
No, we say ISRO. ISRO is correct.
Okay. I heard some people like actually spell it out, and I'm like, ISRO, that just takes too much energy. But yeah. So hopefully there's another mission for ISRO. But yeah, there's so many cool things I think right now, just with like rocket exploration to the cosmos. I think it's such a, and then even there's like other companies working on stuff too. I mean, got Rocket Lab launching satellites to space. You've got Archeon Space, and you've got there's like from ESA, European Space Agency. So that there's so much right now in development. And then Hayabusa 2 just returned to Earth from the asteroid.
Yeah, I saw your story. Yeah.
Oh my gosh, I was so. Has anyone seen that video? Hayabusa 2. It's the first asteroid return mission. First time we got an actual physical sample of an asteroid. Just returned to Earth yesterday. It was this Japanese, so JAXA spacecraft. So exciting. So yeah, there's so many amazing things happening right now.
Which subject's knowledge is needed to become an astrophysicist? So my take is that you just need basically a little bit of maths and a little bit of physics, and you join them together and you get astrophysics. So that's the basic thing. Do you have anything to add?
I would say, let me think. So when I was actually in university, I was like totally crazy with like my classes. I was actually a split major between physics and theater, and then I was mining in astronomy because but that was my minor because they didn't have that as like a major option, which was like kind of unfortunate because they had an observatory on campus. But I think that I wouldn't say like, you guys need to have like a theatrical background, nothing like that. But I think there's with astronomy alone, it has such an open-mindedness to it that yes, for sure the math, for sure the physics, you want to understand chemistry, you want to understand biology, especially if you guys want to eventually become an astronaut, to go to space. There's so many things that if you have more traits just like, up your sleeve, it'll be so helpful, and so I think being able to have that would be important. But I think that just for astronomy is it seems quite obvious in this chat that like a lot of people already have the passion. And I think that if you have that passion, then that's,
Exactly. You need curiosity, you need passion, and then the study. If you don't have curiosity, if you don't have passion, all the maths and physics in the world is not going to help you become an astrophysicist. So I'd like to touch upon a little bit about Ultra Shroff Bhavik's question, how to become an astrophysicist from India. So I'll just like to explain a little bit about what you can study in India and become an astrophysicist. So once you're done with your 10th grade, for 11th and 12th, you do science. And after 12th, there are some great institutes like Indian Institute of Astrophysics, where you can get admission for a 5 years course initially, I think. So it's also graduation and masters, so both together, bachelor's and masters together. So you can do that, and that's, one of the ways that you can become an astrophysicist. But basically, I think astronomers who are working more in theory and physics, they can call themselves astrophysicists. In fact, my argument is that each and every person who's interested into astronomy is an astronomer, basically. So those who are doing science communication, they're astronomers. You don't always have to have a telescope and observe the stars and gather data to become an astronomer. You don't always have to have a degree to become an astronomer. Even if you have the curiosity, and if you're here for this live, if you log on to AstronEra, if you just go on Athena's website or attend one of her talks, you are an astronomer already. So, to become theoretical astrophysicist, there is an academic way that I just explained. Indian Institute of Astrophysics in Bangalore is one of the greatest institute that you can study astrophysics in India.
I love that. I hope to visit that one day. I want to go.
Yeah.
That would be so
There
awesome.
are so many beautiful observatories. We have the Indian Institute of Astrophysics has an observatory in the northern parts of India near Leh Ladakh. So it is kind of a cold desert, and I think it is the highest latitude observatory in Asia. It is beautiful from up there. They have a 2-meter telescope. They also have, I think, the Gamma Ray Observatory. Such a beautiful location, serene skies with no light pollution. And there are so many observatories like this, the radio observatories, optical observatories, all across India, and they're all worth a visit. Even in Pune, we have Inter-University Center of Astronomy and Astrophysics, IUCA, short form. So they are also doing lots of research. They also have an outreach branch, and they're doing lots of stuff for science communication. So that is also worth the visit if you're ever around. Also, another question, Athena, before I forget, I'd like your take upon is, lots of people ask me, and even right now in one of the chats earlier, Aishwarya Khilari has asked that why studying astronomy or getting into the field is important for the nation's development, or overall, why one should study astronomy. What do you think?
Yeah, I think that something I usually, I think, say quite often to like just my personal friends and family. I don't really say it too often, I think, on interviews, is, if we subtract economy and government, and we subtract the industrialization that we have, we take away the buildings, what are we at the end of the day? We're biological beings on a rock that's flying through space in a ever-expanding universe as of right now. I've actually have the expansion of the universe theories right there. I painted with some students that I work with. But so at the end of the day, I think that being able to sort of understand our place in the universe, not just from the perspective of here on Earth, but of our galaxy, our area in the universe as it's expanding, understanding the cosmic microwave background radiation, all of that is going to bring, I think, such a different perspective of not only yourself alone, but also how you see everybody else, your planet, each other.
Yeah.
And, some people might think like, oh, but like science is science, and then you have economy is economy, and then you have government is government. But I've noticed that a lot of people who have a scientific perspective of what our reality is, they have such a different view of how, say, like policies should be made, as an example. Look at the Outer Space Treaty of 1967. The whole purpose was to preserve space for the exploration of science, not to be owned, not to be, have war, all this other stuff. And I think that if we really do shift back to that sort of like almost natural perspective of where we really are, that can change, I think, tremendously of how we treat each other here on this planet. And I know that might be like super sappy. Everyone's like, oh, that's nice, Athena. Like, that's kind of a really like hopeful way of thinking, but it's really a tangible way of thinking. Like I have never met an astronomer who doesn't have an open-mindedness to how we can better treat people. And honestly, for examples, I had some people, some of you guys leave comments in the chat asking for book recommendations, and the book Billions and Billions by Carl Sagan. I mean, I could just stop right there saying Carl Sagan, but like Carl Sagan had such a different mindset, especially towards the end of his life when he knew that he had cancer and was dying, of just how different our world, can be and should be in a more, just aware, I guess, aware world of like how much energy we're using, how our politics are, how our nations can all work together differently for the umbrella of science. At the end of the day, science has always bridged past borders, always.
Yeah, exactly.
You have researchers working together from all over the world. The International Space Station was put together by like 50 different countries. Now you have like 5 or 16 different nations currently working and doing research on there. And, you know, I mean, again, if you guys read scientific journals, which I'm sure a lot of you do, scientific journals have contributors from all over the world. And so what's really innovated and moved us forward to be able to even have this device right now world, despite, you know, like a different background or a different, like, you know, rule based on your country or your nation. So I think that really at the end of the day, like, science is you know, like, this is gonna sound totally cliche, but science is like such a universal language, just like math is. And I think that when people start to learn science, it's like they all start to kind of speak the same language. So I think that, studying astronomy, studying any type of science, whether you guys want to go into engineering or you want to go into biology or chemistry, it's really just, it's enhancing not only yourself, but it's really enhancing this planet. So that's why I think it's so important for anyone to pursue a STEM field.
Right,
That's my view.
Astronomy gives you a whole new perspective towards the entire life. I mean, when Neil Armstrong went to the moon and he just put his thumb up like this, and the Earth, the whole world as we know it, was vanished behind it. So we are, you know, such a small pale blue dot in this massive universe, and it teaches us to be humankind as a species. And as you said very correctly, it kind of make us look beyond the borders, beyond the money, the politics and everything. And scientific temper is something that every human must have to sustain in the world. You know, it is a basic right for everybody. In fact, in Indian constitution, it is written that it is the duty of every Indian citizen to have a scientific temper. So, you know, it is important just to live a beautiful life. I think that's the one basic thing. We also have a course about this, why study astronomy, on our website, and Athena explained just very perfectly about it.
I'm really happy that you guys are here. I'm so happy that that we were partnering together for this. I think, I'm so excited. And I really can't wait. And congrats to everybody who entered, who won. And let's start exploring the night sky. Hopefully, maybe I'll do like some type of like astrophotography tutorial to get the craters on the moon with my DSLR. We'll see. I might be able to do that. So thank you so much to everyone.
Perfect. And thank you so much, Athena, for making time to join us today. I think everybody stuck to it and they enjoyed as well. And I am really grateful for you for making this time for us and for making this whole course. I know how much time it takes to, you know, jot down all the content and then record the video. And then we are going to do all the producing stuff. So that's cool. But it's a long process and you took time to do it. So it's our pleasure to host you as one of our instructors on our website. And guys, you can go on AstronEra's profile and you'll see that in our bio there is link to Athena's course on our website. So you can just click on that and go in the course. If you have any doubt about how to enroll, or if you want a discount, if you have enrolled into the contest or anything, just DM us. We have a nice team to explain to you everything and make this process easy. Is it me? Yes, it's me.
There we go.
Yes.
Okay, you froze right when you were saying it. It was you guys are an amazing team, by the way. You're saying we have a really nice team. If you guys have any questions, you really do. You guys have been so helpful with me through this entire journey. So thank you for
we
that.
all are really great. I mean, they have made the process very easy to handle so many students. We have about 4,000 students enrolled from about 110 countries.
Wow.
So, you know, handling all the aspects, the IT, the social media, the teaching, everything is really overwhelming. And without the team, this couldn't have been there. So, you know,
Yeah.
I am really grateful to everybody in the team.
That's amazing. Oh, amazing.
Yeah.
Well, thank you so much. And I can't wait to release the first episode next Monday. I'm so excited.
Yes. Thank you. And clear skies. Bye
Clear
bye.
skies. Bye, everyone. Thank you.